This is Fahim Muntasir. So, for the Engineering 9857 project, we will discuss about design and penetration control of PV and wind energy systems to supply low-cost continuous power to a remote community in India. This project is supervised by Dr. Mohsin Jamil. So, these are the outlines of the project. As you can see, first we will start with the problem statement, then followed by solution, introduction to the hybrid energy system, project methodology, community selection, project modeling and resources, case study, controlling method, financial analysis, and finally the conclusion. So it is always essential to conduct a feasibility study to set up a renewable energy plan because it involves a considerable amount of upfront cost. So a good feasibility study is required to determine whether the project will be feasible or not. And the constantly changing input of the renewable energy sources might result in either capacity shortage or generating more power than the demand. For example, the PV cell might produce more energy than consumption in the sunny day, but in the cloudy day, it might produce less energy than the consumption. So it results in capacity shortage. So that is why we are considering here to establish a hybrid energy system. So if one of the sources is not available, then other sources will be able to cover the deficit. And India faces a terrible power system reliability problem, especially in the rural communities. As you can see, that 71% of the total village households has been electrified in India. And among those households, Jharkhand has the lowest household electrification level of just 39%. So in this project, we will focus on this remote community to develop an hybrid energy systems. And another thing is that most of the remote locations which are isolated from the grid have to rely on standalone diesel generator system. So for this diesel generator system, the consumer has to pay high electricity bill because the government do not provide any kind of subsidies to them. So this is a diagram of a hybrid power system. As you can see that a hybrid power system consists of a PV module and wind turbine with a battery bank system, and there is a diesel generator as well. So some of the strengths of the hybrid energy systems are it can reduce the reliance on fossil fuels and increase the share of renewable energy systems. Hybrid systems can reduce energy costs in the long run, and setting up isolated grids can help provide modern energy access to remote areas and avoid the cost of expensive, which I just mentioned earlier. So in the project methodology, first we will select an appropriate site with the available potential resources to implement a hybrid power arrangement because we need to get the record of the annual wind speed and annual solar radiation and other factors in order to set up a renewable plant. We'll design the overall system in HomaPro software consisting of a solar and wind turbine. The penetration of the renewable sources will be calculated based on the generation consumption and the amount of excess energy. Then we'll design a controller in MATLAB similarly to accurately control the penetration of the systems. And the last of all, we will compare the levelized cost of energy with the grid connected system to see the difference between the off-grid energy system and the on-grid energy system. So as you already know that we are going to set up this hybrid renewable energy system in Jharkhand, India, because it has the lowest electrification rate in India. So it is essential to analyze the site resources of this location. That's why we have collected the annual wind speed data and annual solar irradiation data. So from this curve, we can see that the annual average wind speed of the proposed location is 4.27 meter per second, and the solar radiation is 5.13 kilowatt hour per meter square per day. So what we have thought that this data is suitable enough to establish a PV and wind energy systems. And the last of all, the India is located in the equator region, so solar irradiation is always high in here. So the PV system will provide the maximum efficiency in this area. So in order to calculate the load consumption, as we do not have any smart meter to get the live load data, so we actually get the help of a research paper from Google Scholars. So based on that research paper, we actually calculate the average energy consumption and appliance usage patterns in India. So as per that paper, the average load consumption in India in that particular area is 5.28 kilowatt hour per day. So we have selected two residences in here for this project. And as per the load consumption, we have selected wind turbine, PV cell, and battery storage systems. Actually, the size of the wind turbine, PV cell, and the battery storage system is calculated as per the energy equations. So here we have two renewable energy systems. One is wind turbine and another is PV cell with a battery storage system. And we have inverter as well because PV is producing DC output. So we need to convert it into AC to feed the voltage into the residences. So these are the specifications of the wind turbine. So we have selected a wind turbine from Lotus Energy Technology Corporation Limited, and the capacity of this wind turbine is 1 kilowatt, and the type is vertical axis wind turbine. The hub height is 9.90 meter, and the lifetime of this wind turbine is 20 years. We have selected a solar panel as well. So it is from generic flat plate PV, and the capacity of this solar panel is 1 kilowatt as well, and it is a flat plate type solar panel, and it is lifetime consists of 25 years. This is the specifications of the inverter. So the inverter is from Struder Innotech, and the voltage, nominal voltage of the inverter is 12 volt, capacity is 2.1 kilowatt. The inverter is actually selected as per the peak load of the residence. So the peak load of the residence is almost 2 kilowatt. That's why we have selected an inverter of a 2.1 kilowatt, and the output voltage is 230 volt AC because the most of the appliances in India uses 230 volt AC voltage. Frequency is 50 hertz because the standard frequency in India, and the operating temperature of this inverter is minus 20 to 50 degrees centigrade. So after the simulation in HomaPro software, we have generated this following table. So before doing the simulation in HomaPro software, we put the penetration percentage at 70% and 30% from PV and wind turbine respectively. So naturally the PV will produce more power than the wind turbine, as it shows in the table 2. The PV is producing 3078 kilowatt hour per year, whereas the wind turbine is producing 2266 kilowatt per year. The actual penetration is 57.6%, and the penetration of the wind turbine is 42.4%. And the total load of the residences are 3856 kilowatt hour per year, and the levelized cost of energy of this system is 0.6450 cent. So now we need to design a controlling system, because to get the maximum efficiency and maximum output from both systems, we need to design an appropriate control system. So first of all, we will discuss about the controlling arrangement of the PV system. So the HomaPro software gives the penetration of PV cell is approximately 60%. To be accurate, it is 57.8%. So to ensure the most cost efficient output from this PV cell, we need to extract the maximum output from the solar panel regardless of the external factor, because the voltage and the output temperature or the ambient temperature might deviate the output of PV cell. So regardless of these circumstances, we need to ensure the PV cell can produce maximum output. So in order to do this, we will use an MPPT charge controller so that the PV cell can deliver the maximum possible output to the load appliances through the battery storage system. So this is the proposed PV system arrangement. As you can see that we will use a DC to DC boost converter, and we will use an MPPT charge controller. So this MPPT charge controller will be integrated with an algorithm. So this algorithm will take the feedback of voltage and current. So based on its feedback, it will feed the voltage to the DC to DC boost converter, so that the DC to DC boost converter provides maximum output to the battery storage system, so that the PV system can maintain its maximum efficiency. So this is the circuit diagram of the boost converter. So as you can see that there is a PV cell and there is an MPV charge controller. So it will get the feedback from the PV cell, and based on that feedback, the MPV charge controller will control this duty cycle, and duty cycle will control this MOSFET. I mean, as per the requirement, it will turn off or turn on this MOSFET and provide maximum load to the system. And we will actually integrate incremental conductance method in this MPPT. So this method will maintain maximum output from PV cell irrespective of external factors. So this is the flowchart of the incremental conductance method. So from this flowchart, as you can see that there is a maximum power point available. I mean, when di divided by dv equal to minus I by v, then the PV cell will be in the maximum power point system. So when the voltage will deviate from the right hand side or in the left hand side of the maximum power point, the incremental conductance method will act accordingly and put the level of voltage and current always to this maximum power point. So when di by dv greater than I by v, so it is on the left hand side, so it will increase the duty cycle and put the point in this maximum power point. Or when di by dv less than I by v, so the duty cycle will be reduced and the voltage will shift it to again to this maximum power point. So by integrating this method, the PV cell can maintain maximum power output. So we have designed this boost converter circuit in MATLAB Simulink. So as you can see that this is the PV cell and the solar irradiation and temperature has been input in here, and this is the MOSFET switch and this is the battery storage system. And in the duty ratio block we have actually integrated the IO conductance method. So based on the mean temperature and the variation of solar irradiance, the voltage of the cell will be deviated. So when the voltage and current of the cell will be deviated, the duty ratio will operate and it will control the output voltage and current to the required level so that the battery storage system can operate at the maximum efficiency regardless of this irradiance and output temperature. So this is the effectiveness of the MPPT charge controller. As you can see that, so in the first figure, in the A figure, when the solar irradiation is 1000 watt per meter square, so it maintains 2000 watt power output constantly. And when the solar radiation reduces, so the output power has reduced as well. So as you can see that there is a small deviation at the beginning, but after that it constantly maintaining 1000 output power. So we can use this MPP charge controller, and if there is any variation of the voltage or the temperature or the solar irradiation, the PV cell will maintain constant power output at every second. So now we will talk about the control system of the wind turbine. So as per this table, you can see that the scenario 1 gives us the most feasible LCOE when the penetration of the wind turbine is 30% and the penetration of the PV cell is 70%. But if you increase the penetration of the wind turbine and decrease the penetration of a PV cell, so the LCOE continuously increasing. So we have to maintain the penetration of the system at the desired level so that the LCOE cost is at the minimum level. So we need to implement scenario 1 in the control system so that the wind turbine generation do not exceed 30% of the total generation. And when the generation of the wind turbine goes beyond 30%, then by pitch control mechanism of the control system, the wind turbine will reduce the generation down to 30% again, and the rest of the generation will come from the PV cell. So in order to achieve the desired penetration of the wind turbine, a PI controller is developed to calculate the output percentage of both systems. So depending upon the percentage of both systems, this PI controller will act accordingly. So this figure shows that when the penetration of the wind turbine goes beyond 30%, the control system will start doing responding, and the output percentage of the wind turbine and again goes down to 30% within 1 second. So the controller has less than 5% overshoot and is accurately tracking down the penetration of the wind turbine. But in case of unavailability of the solar resources, then the percentage may vary, and then the control system will allow the wind turbine to operate more than 30% level. So now we are going to the financial analysis in here. So we will do the financial analysis as per the rate of investment percentage. So the higher the rate of the investment percentage, the project is more feasible. So the rate of ROI is actually based on this formula. So final value of investment minus initial value of investment divided by the total investment cost. So by getting these figures, we will calculate the percentage of ROI. So we have calculated the total investment cost in here. So you can see that the initial investment cost was 17,220 US dollar. The final, which includes the weighing cost, uh, gives us 25,709 US dollar. So based on this figure, we will calculate the off-grid ROI. So the off-grid ROI comes as 33.01%. But as for on-grid ROI, the ROI percent increases to about 10%. So it is now 43.19%. The reason is why, because in the on-grid system, the power is actually available from the grid. So instead of setting up a bulk size renewable system, we can buy a small size renewable system and can get the remaining power from the grid. So it gives us higher ROI and less NPC and less LCOE as well. So this ROI calculation proves that the on-grid energy system, on-grid hybrid energy system is financially feasible than the off-grid ROI system. But it again depends upon the particular location of the project. Because if the project is location from far away from the city, or the transmission or distribution line will not be able to be set up, then the customer have to go for off-grid ROI. But if there is any possibility to establish a grid infrastructure, then the on-grid system will be far more feasible than the off-grid system. So in the conclusion, so we have conducted a techno-economic analysis of the hybrid renewable power system in Jharkhand in India. So the reason is why we have considered hybrid energy system, because the single renewable energy system might result in capacity shortage or produce more power than the actual demand. And by choosing the renewable power system as a hybrid basis, we also reduce the size of the battery storage system as well. And we have make a comparison between the on-grid and off-grid hybrid systems, and as you can see that the on-grid system gives a better financial feasibility than the off-grid system. And we get the most optimum results from the HomaPro software when the penetration of the wind turbine set at 30% and the penetration of the PV cell set at 70%. To accurately control this penetration, a PI controller is developed and it accurately maintains the penetration percentage to get the maximum power output from the whole system. And we also developed an MPP charge controller with an integration of IC algorithm, because as we are getting more power from the PV cells, so it is important to ensure that the PV cell provides the maximum power output all the time. And last of all, proper financial support from the investors and the government will help to electrify more villages in remote community. And also the most important thing is that the grid operators will be able to reduce their transmission and distribution costs.